Alright, let me try to quickly go over the Chapter 6 quiz. Problem number 1 from the quiz should have been a no-brainer, a real quick one. If the derivative of tangent is secant squared x, then integrating secant squared x will be tangent, so it's tangent x plus c. There's a plus c because it's an indefinite integral, and that's it. So knowing your rules for integration, especially integrating trig functions, would have helped you quickly answer problem number 1. And now we're on to problem number 2. Problem number 2 is a u substitution problem. So if you allow u to be 3x squared plus 5, and the derivative with respect to x is 6x, okay, that's the same as, after you rearrange, you have dx is equal to 1 over 6x du. So now what we have is 1/6 times the integral of x over the square root of u du over x. So what I did was I took out the 1/6, that's why I have this 1/6 out here, and 1 over x du is this one right here. So now we see that the x is cancelled out, and this is the same as integrating 1/6 times the integral of u to the negative 1/2 du, which is 1/6 to radical u plus c. So that should be d after u. Oh, you need to cancel out the 6 and the 2, or simplify. So after you do all that, you see that you get 1/3 3x squared plus 5 to the 1/2 plus c. The square root of 3x squared plus 5 is the same as 3x squared plus 5 to the 1/2. So D is your answer. Alright, so let's move on to problem number 3. Problem number 3 is another u substitution, but this time we have limits on it. So it's a definite integral, so we have to treat it a little different. But we started the same. We can let u equal 1 plus sine theta, making du d theta equal to cosine theta, which is the same as d theta equals 1 over cosine theta du. So now what I have here is the integral. Now I have, let's see, cosine theta over the square root of u times, and then, so I'm going to go ahead and show my work this time. I didn't really show this work in problem number 2, but hopefully showing the work will help some of you guys see how the cosine in this case cancels out. And we're really just looking at a similar integral from as the last time. Okay, now this is the same as the square root, let's see, this is the same as the integral of u to the negative 1/2 du. That's what I meant, right? Okay, now we can integrate this And notice that it's the same as very similar to problem number 2. So it's 2 radical. Now instead of u, I'm going to resubstitute the 1 plus sine theta. Now that I have integrated, and I have from 0 to pi over 2. Okay, so what I'm going to do is 2 times, so this is pretty much 2 times the square root of 1 plus sine of pi over 2 minus 2 times 1 plus sine of 0. That's a 0, not theta. So sine of 0. So you get 2 radical 1 plus 1 minus 2 radical 1 plus 0. This is 2 radical 2 minus, now this is 1, so square root of 1 is just 1 times 2 is 2. So this is the answer, or 2 radical 2 minus 1 after we factor out the 2, and you can see that that's D. Alright, so the answer is D. Let's do problem number 4. For problem number 4, you should realize that you have 2 trapezoids. I mean, you could have done this in many ways. You could have done triangle, rectangle, triangle, triangle, and a rectangle, or a square. The last one's a square. But you could have also seen this as 2 trapezoids. So base 1 plus base 2, that's 1, 2, 3, 4. And the height is 2 divided by 2. That's 8 over 2, or 4. Now that's positive because it's up here. It's above the x-axis. And then what we have here is base 1, 1, 2, plus base 2, that's 1, so 3. The height is 1 over 2, so that's 3 over 2, but it's negative because it's below the x-axis. So what we have here is 4 minus 3 over 2. That's 8 over 2 minus 3 over 2. And this should be B. Okay, that's problem number 4. Alright, problem number 5, you could have done it 2 different ways. You could have easily graphed the absolute value of x minus 2. Or you could have considered the piecewise function. And considering the piecewise function, you can now break the absolute value of x minus 2 when you're integrating from 0 to 3. You can break it down to 2 integrals, the sum of 2 integrals. So it's the integral from 0 to 2 of negative x plus 2 dx plus the integral from 2 to 3 of x minus 2 dx. And real quick, I just want to add in that I got negative x plus 2 because it's negative parentheses x minus 2, and when you distribute the negative, it's negative x plus 2. Alright, so then you would integrate these separately and you'll get your answer. Add them up and you'll get your answer. So I'm just going to go ahead and show you the work to try to speed this video up. Alright, and to finish off applying the fundamental theorem of calculus, you have to apply it to both of these separately. So you're going to input the 2 for x minus and then the 0. The nice thing about 0 is when you plug it into this antiderivative here, it's going to be 0 still. And then you're going to do it here again, input the 3, and then you're going to subtract inputting the 2. Okay, so when I plugged in my upper limit of 2, that's what I got. When I plugged in my lower limit of 0, well, that's easy, that's just 0 there. And then I did the same thing for the other one. I plugged in the 3, and I got this. And then I plugged in my 2. This time it's not that easy, so you get 2 minus 4 after all the work is said and done. Okay, the rest is just computation and you'll get your final answer.